Hello, welcome to another video. In this video, I'm looking at the audio frequency response and the power consumption of the HomePod Mini. From this information, we can take an educated guess at the size of the power amplifiers and figure out how much sound output you can expect from your HomePod Mini. The tools used to measure the performance of the HomePod Mini are a Dayton OMNI mic and a Hoppy power analyzer. The other equipment required is a phone with AirPlay and some basic audio tracks to stream to the device. The Dayton OMNI mic is just that, a microphone. It's connected to a test and measurement software package that can analyze various parameters of loudspeakers and spaces. In this case, we're using a frequency response test to determine how the loudspeaker's output changes over frequency. So how much sound does it put out at
low frequencies?
And how much sound does it put out at
higher frequencies?
This is one of the most important tests for loudspeakers, which is why it's being presented here. There's numerous other parameters, but they're beyond the scope of this video. A hint, total harmonic distortion. The acoustic measurements were done in a free field over a reflecting plane, otherwise known as a big, flat, empty space outside. The reason for doing measurements in a space like this is to cut down on reflections from other surfaces that can cause unwanted effects in the acoustic response of the unit being tested. The measurement distance used is 1 meter. This does not matter a lot, but a lot of acoustic sound pressure level measurements happen to be done at 1 meter, so this allows easy comparison with some other sound pressure readings. Most loudspeakers are rated in dB at 1 watt and 1 meter for sensitivity, for example. The sound levels are in decibel, or dB, which is a log scale and it's unitless. This is a whole topic for another video. For now, what you need to know is 50 dB is fairly quiet, 70 dB is moderate, and 100 dB is pretty loud. Two devices were tested. One is a Bang & Olufsen Beoplay S3. It's a Bluetooth powered speaker. And the other is, of course, the Apple HomePod Mini. Here's a frequency response graph for the two loudspeakers. We can see the HomePod Mini is around 75 dB, so it would play in the moderate sound level, which is about how loud it sounds. In a small room, this could probably achieve 80 to 85 dB peak sound pressure levels. In a large room, it will not be very loud. The Beoplay S3, on the other hand, plays quite comfortably around 96 dB, which is near the loud end of the scale and can be used in somewhat larger rooms to achieve music sound pressure levels that can be perceived as too loud even. The power consumption of the HomePod Mini follows a pattern as well. At the lowest frequency, where it starts to produce audio, the power consumption is low, but then it scales up to around 13.5 watts at 70 Hz. The most sound is produced at 100 Hz when the speaker is using 12 watts. From there, it tapers off to 2.7 watts at 1 kHz. The Beoplay S3 follows a similar pattern, but it starts producing sound at a much lower frequency of 15 Hz with 2.8 watts consumed, with a peak of 22.2 watts at 45 Hz and tapering down to 5.2 watts at 1000 Hz. Oddly enough, the Beoplay also has the 100 Hz bump, which can be seen in the power consumption of 11.3 watts at that frequency. From the online specification sheet, we know the Beoplay S3 has a 35 watt RMS amplifier for each driver. Only one is active during each of these tests because we're using a sine wave. Based on the power consumption data, being about half of the maximum value in the case of the HomePod Mini, we can guess that the amplifier has an 18 watt RMS amplifier. The sizing of the wall adapter at 20 watts would accommodate this amplifier size. Although most of the time the HomePod Mini will be using less than 10 watts to achieve the short bursts of dynamic music content, so the power adapter will only need to supply that full 20 watts occasionally. So, the key takeaways here are the fact that both devices actually sound pretty good. The HomePod Mini is clearly made for a smaller space, is physically much smaller, and has less lower frequency content due to its smaller loudspeaker, smaller enclosure, and smaller amplifier. It's not going to be a party loudspeaker, but for a reasonable cost, you get a compact and good sounding smart speaker. Check out the comments section to see more information, and thanks for watching. Like and subscribe.